Worksheet 4, 1.6, and 1.7. On this worksheet, you're going to be looking at solving different types of equations. The first ones we're going to look at is ones with radicals. For the first equation, if I'm trying to solve for x, one thing that's standing in my way is this square root. So to get rid of a square root, I need to square it, but before I can do that, I have to first isolate it. So to isolate this, I'm going to bring my 10 to the other side. I end up with 10 minus x equals the square root of x plus 2. To get rid of my radical, I will square this, and whatever I do to one side, I do to the other. Square it all out, I get 100 minus 20x plus x squared is equal to x plus 2. My square and square root cancel each other out. I'm going to make this look a little bit nicer and rewrite this side as x squared minus 20x plus 100 in standard form equals x plus 2, and then bring all my variables to the other side. So x squared minus 21x plus 98 equals 0. This factors, so x minus 7, x minus 14, which is 0, and when I tee this up, my solutions are either x equals 7 or x equals 14. Looking to the next one, seems slightly more complicated, but it's the same basic procedure. I'm first going to isolate one of my two radicals. So I end up with the square root of x minus 2 is equal to 3 minus the square root of 7 minus x. Now I'm going to square both sides. When I square both sides, on my left-hand side, the square root and the square will cancel each other out, inverse operations. On the right-hand side, I will have to FOIL, since I have a binomial. I end up with 9 minus 6, square root of 7 minus x, plus the square root of 7 minus x squared, which is just 7 minus x. I'm going to combine all my like terms now. If I bring all of my constants together on the right-hand side, I end up with x minus 2 equals 9 plus 7, which is 16, minus x minus 6 square root of 7 minus x. Just cleaning this up so I can see things a little clearer. I'm now going to bring all my x's and constants from this side over to isolate my perfect square. When I do that, I end up with 2x minus 18 equals negative 6 square root of 7 minus x. Now your instinct may be to immediately square everything, but notice everything has a common factor of 2, so I can make this question easier for myself if I divide everything by a common factor of 2. What happens when I do that is I get x minus 9 equals negative 3 square root of 7 minus x, which when I now go to square this to get rid of my radical, I'll get slightly easier and nicer numbers. When I square both sides, my left-hand side will become x squared minus 18x plus 81, which is equal to negative 3 squared, which is 9, times the square root of 7 minus x squared, which is just 7 minus x. I'm now going to distribute the right-hand side. I end up with x squared minus 18x plus 81 is equal to 63 minus 9x. When I bring everything to the left-hand side, I end up with x squared minus 9x plus 18 is equal to 0, which does actually factor to x minus 6, x minus 3 equals 0. So I get my final form answer as either x equals 3 or x equals 6. Now we're going to look at some higher power equations. If you notice that the exponent of my x to the 4th is twice that of my x squared, so this is actually of quadratic type. I can factor it like I would any other quadratic, only instead of x's, I will have x squareds. I'm looking for what adds to 5 and multiplies to negative 36, and positive 9, negative 4 will do the job for me. But then I'm going to notice that I'm not quite done factoring because x minus 4, x squared minus 4, is actually a difference of 2 squared. So x squared plus 9, x minus 2, x plus 2 equals 0. So that when I find the solutions to this equation, either x squared equals negative 9, which means that x would be plus or minus 3i, an imaginary number when I take the square root of a negative, x equals 2, or x equals negative 2. So my final solution is x is plus or minus 2, and plus or minus 3i. Note that when I have something to the 4th power, I might expect 4 solutions, and that's exactly what I received. For the other one, to make things easier, I'm first going to factor out a GCF. Here's greatest common factor of 27. I end up with x cubed plus 8 equals 0. I can then divide both sides by 27 to make my life easier, and I end up with x cubed plus 8 equals 0. I'm going to factor this using my cubic formula. I get x plus 2, x squared minus 2x plus 4 equals 0. Remember, the signs are the same, different, always positive whenever I'm factoring a perfect cube, or sum of 2 cubes. And when I go through solving these two equations, either x equals negative 2, or I could do completing the square on this result. If I do that, I end up with x squared minus 2x is equal to negative 4. When I complete the square, half of negative 2 is negative 1. Negative 1 squared is plus 1. Whatever I add to one side, I also add to the other. So I end up with x minus 1 squared is equal to negative 3. When I take square roots of both sides to solve for x, I end up with x minus 1 is equal to plus or minus I times the square root of 3, which when I solve for x is 1 plus or minus I rad 3. That would be my imaginary solution. I have one real solution, x equals negative 2, and two imaginary solutions, 1 plus or minus I rad 3. Whenever I'm solving an absolute value equation, I have to first isolate my absolute value. So I'm going to add 3 to both sides. And I get 6 times the absolute value of x minus 5 equals 18. Divide both sides by 6. The absolute value of x minus 5 is 3. And this value, x minus 5, has both a positive and a negative solution. Remember, absolute value means distance from 0. I have distances to the left, which are negative, and distances to the right, which are positive. So I get 2 equations from this. X minus 5 equals 3, and x minus 5 equals negative 3. That means that either x is 8 or x is 2. 2 solutions. The other one is an absolute value inequality, so I'm going to have to be a little bit more careful. To solve this out, I'm going to start by multiplying both sides by 2. With the absolute value of x plus 1 is less than or equal to 6. Isolating my absolute value just like I did before. But now I have to be careful because I have an inequality sign. This will give me 2 equations. Again, x plus 1 is less than or equal to 6, or x plus 1 is greater than or equal to negative 6. My signs change, the directions of my inequalities also change. So x is less than or equal to 5, or x is greater than or equal to 7. I can combine these 2 equations into a single line of information. X is less than or equal to 5, but greater than or equal to negative 7. My final answer. And finally, for this one, it's a similar process. I'm going to divide both sides by 3. I end up with 4 minus 5x greater than or equal to 3. Again, I will have 2 forms of this equation. 4 minus 5x is greater than or equal to 3, or 4 minus 5x is less than or equal to negative 3. When I solve this out, I get negative 5x is greater than or equal to -1. Then I'm going to divide both sides by -5. Remember, when I either multiply or divide by a negative, it's changing the direction of my inequality. So I get x is less than or equal to 1/5. And for the other one, -5x is less than or equal to -7. So when I divide by my -5, x is greater than or equal to 7/5. So either it's less than 1/5 or greater than 7/5. Do not make the mistake do not make the mistake of writing this as a single line, because it is impossible for x to be greater than or equal to 7/5 and less than or equal to 1/5. 7/5 is bigger than 1/5. This, as an answer, makes no sense. So I'm going to leave it as separate inequalities, because it's either x is less than 1/5 or x is greater than 7/5.